In this video, we're going to perform optimization on an EM structure in AWR Design Environment or Microwave Office. And we're going to be optimizing this structure here. So we're looking at a top-down view of a microstrip low-pass filter with a cutoff frequency of 4 gigahertz. Okay, so I've started a new project, and now let's create a new circuit. So here at the left in the project browser, we right-click on Circuit Schematics, and then click on New Schematic, and we can call it Schematic 1. That's fine. Okay, before we lay anything out, let's go up here to Options, Project Options, and I already know the frequencies we're going to simulate, so let's put that in. We're going to go from 0.5 gigs to 7.5 gigahertz with steps of 0.01. We can hit Apply. And now let's change the global units, frequency to gigahertz, and length to inches. And everything else we can leave, ignore that warning. And let's start laying out our circuit. So our goal again is to lay out this circuit, but using these discrete elements. Okay, first thing we need to do is define our substrate. So here I clicked on the Elements tab down here at the bottom left, and now I'm going to click on Substrates and find M sub. That's our microstrip substrate definition. Dielectric constant, epsilon r, is 1.96. Height, 0.05 inches. Metal thickness, 0.000138. Rho, which is the conductor resistivity normalized to the resistivity of gold, it's 0.689. Our conductor is copper. Loss tangent will make 0.001, and we'll change this to 1.96 as well, so it matches our epsilon r. Alright, so let's start. So we're going to have port, we go up here to the upper right to ports, and this is port 1. And now we're going to connect it to a 50 ohm line. So let's go to microstrip here in the project browser. Look for lines. And M line is what we want. So we bring M line over here. And the width is 0.281. That corresponds to 50 ohms. Let's just make this, I don't know, 0.4 inches. Okay, now this is going to be connected to a T-junction. So here in the left, under the elements, click on junctions, and we look for MT or T-junction and bring that over. W1, we're going to have it match with this W, so there's no discontinuity there. So that's going to be 0.281. W2, because this is connected to this middle part, we're going to call this just W underscore middle. And W3 is connected to a stub that's on the side, so let's call it W underscore stub side. And we'll put numbers for these variables in a moment, but let's lay this all out first. Okay, so we can go back to lines, and let's get another M line and bring that over here. And this W is going to match with W2, so we're going to call this W underscore middle. And length is going to be L underscore middle. Let's put another T-junction, so Control C, Control V to copy and paste. W1 is going to match with W middle, so we can go W middle. W2 is going to be W middle, so that stays the same. And W3 is going to be W stub middle. And I'm going to highlight this line, Control C to copy, Control V to paste. W middle, L middle, all that stuff is fine. And then let's bring another T-junction, so Control C to copy, Control V to paste. W1 is going to be W middle. W2 is going to correspond to a 50 ohm line because we're going to connect that to a port, so 0.281. W3 is going to be W stub side. I'm going to go here to this first transmission line, hit Control C, Control V to copy and paste it, and then let's have another port at port 2. So I'm going to click on that and hit Control R to rotate. And then connect. And let's put our stubs in. So we go here to line, and MLEF is the open microstrip line with end effects. So we're bringing that over. I'm going to highlight it and then hit Control R to rotate. Move that there. Now this width is going to be W stub side. And this length is going to be L stub side. And by symmetry, there's going to be one. So I hit Control C and then Control V. There's going to be one here on the right. Let's put one here in the middle. We'll change these variables. So we leave these two, the left and the right, the same. But the one in the middle, we're going to change side to middle. Okay, now what are the values for all these dimensions? Let's define our variables. So we'll do it right here in this left. So up here at equations, I click, bring it down, and then I'm going to go W middle is equal to 0.147. I'm going to copy and paste it a few times. So now we have W stub underscore side 0.047. That's equal to 0.047. And then W underscore stub underscore middle is equal to 0.138. Now I got these values by just designing the filter. In the end, I used Posar's Microwave Engineering textbook to get the basic design. But this tutorial is not concerned with how we design a low-pass microstrip filter. It's concerned with how to perform an optimization on an EM structure using Microwave Office. So I'm not going to discuss exactly more on how exactly I got these values, but because that's not what's relevant for this tutorial. So I copy them all, then pasted, and we need to define our length. So we have L middle is going to be 0.212. L stub side is 0.217. L stub middle is 0.393. Okay, so to check if I'm right, if we didn't make mistakes, let's click here in the project tab below, up or bottom left, and we go to graphs and we go new graphs. And let's create rectangular. So I right clicked on graphs, hit new graphs, and now rectangular. I'm going to right click here and click on add new measurement. And let's look at S11 and DB. So I click on DB and S11 is set, apply, and then change this to S21 and hit apply. And then we'll click on this lightning bolt to analyze. The pink curve is S21. And indeed, you can see that it's acting as a low-pass filter. So it's passing all these frequencies up to about 4 gigahertz, and then past 4, it attenuates the signals. Okay. Let's now go to View and Variable Browser, and we need to tell the software what variables we want to optimize. So they're listed all up here. There's 6 of them. 1, 2, 3, 4, 5, 6. And when you're performing an optimization on an EM structure, you need to constrain it. It's just one of the things you have to do. So I'm going to make the lower and upper. I'm not actually that concerned with the lower and upper values. I'm just going to kind of eyeball it. So this is 0.047. We'll make the lower 0.01 and the upper 0.1. Let's make this one the lower 0.1 and the upper 0.2. This lower, we'll just make 0.1, 0.3. This L stub will make 0.1 as the lower, and the upper 0.3. The middle will make 0.1, upper 0.2, 0.2, 0.5. And then we're going to define the step size as 0.001. I'm going to highlight it, hit Control C to copy, and then paste it on all these different variables. Okay, that's the first thing. Second thing we want to do is create our optimizer goals. So here in the project browser, I right click and hit Add Optimizer Goal. Now you'll see S11 in DB and S21 in DB. These are showing up because we've already created measurements for them in the graphs. Had we not looked at this graph here and we didn't have S11 and S21, then these wouldn't even be options. So that's how you can, that explains why these things are showing up under measurements. So S11, we want to be measured S11 to be less than -10. 10 dB is our goal. And we want that to be in the pass band, so up to 4 gigs, because 4 gigahertz is our cutoff frequency. And I hit OK. And you can see in the graph that that goal is displayed right here as this horizontal bar that's placed at -10. And what this indicates is it's saying we're optimizing so that this blue curve is less than the bar. Right now, it is actually, so it is meeting that goal. Again, we go to Optimizer Goals and click on Add Optimizer Goal. Let's go for S21. S21, we want it to be greater than -0.5 in the pass band. So that's up to 4 gigs. So I changed max to 4 gigahertz. And that goal shows up. Optimizer Goals again. Right click, hit Add Optimizer Goal. Let's go for S21. And now we want to talk about what's going on after 4 gigahertz. So we want S21 to be less than negative, say, 13 dB at, say, 4.8 gigs and on. There's that goal. So you can see that the pink curve doesn't quite meet the goal. And that's the whole point of optimizing. We want to find the variables that will, or the correct dimensions so that this pink curve does meet the goal. I should also say that these curves are the curves, are corresponding to this schematic that contains these microstrip elements in which the model is basically an analytical model. So there's no EM simulation yet, but this will be probably pretty close to the EM simulation. Okay, so let's actually create our EM simulation. So we're going to do scripts, EM, create stackup. Our grid will make it 0.1 inches. Then it creates a stackup block and the extract block. Let's double click on the stackup and go to EM layer mapping, and you'll see copper EM layer 2. Let's change the material to CU copper. Click on the line type tab, go insert, and there's default, and change that to copper, and then go to line 1 and delete it. In this block, this extract block is all ready to go. Now we highlight each element. So I click and hit shift and click on all the other ones. Actually, why is it not working? Whoops. So hit shift and click on all of them. Right click somewhere like here, properties, model options, and go to enable for the EM extraction options. Click OK. Next thing we want to do before we actually extract is go up here to View Layout. We're going to go Edit, Select All, Edit, Snap Together, and that will snap everything together. And this corresponds to the filter I showed at the beginning of the video. We want to go to Options, Layout Options. And right here it says Layout Cell Snap Options, Snap Together. We want to change to Auto Snap on Parameter Changes. That's really important when you're doing an optimization on an EM structure. For the grid spacing, we can do 0.001, and for the database, we can go 0.0001 and hit OK. I think we're ready to extract. So right-click on this extract block, and then go to Add Extraction. And what it does is right here in EM Structures, it creates that EM structure that we're looking at now. Let's take a look at the mesh size. So up here in the top right, we look at Show 2D Mesh. Show 2D Mesh. Click on that. And you can see the mesh that this thing is going to be simulating at. So that looks good to me. Before we actually perform the optimization, let's just simulate the EM structure. So let's close all this stuff out real quick. We've already done our variables. I'm going to clean up this graph a bit. So I'm going to actually click here. It's all kind of grayed out because we've clicked on extract. I'm going to actually just delete these measurements. And then I'm going to add new measurements and just kind of do them again, but make sure the sources is schematic 1. You could do EM structure as well, and it would do the same thing, but let's just do schematic 1. Port 2 ones, that's S11. There we go. Just kind of clean the graph up. Okay, so even though all these things are defined on the schematic, because of this extract block and the way we defined everything, it's going to, when I hit Analyze, it's going to simulate the EM structure. And you can always tell that when you click on the extract block, the things that are red are the things that will show up in the EM simulation. So right there. Okay, without further ado, let's click on Analyze, and it might take a few minutes, and I have my keyboard here to play some music while it's analyzing, so let's go for it. It is still simulating. Okay, more music. All right, it looks like it is done. So thanks for bearing with my piano practice there. As you can tell, I'm out of practice. Okay, so wow, the simulation for the EM structure is almost identical to the structure with the closed form models. Just kind of from memory, it looked pretty much like that. Okay, so we are ready now to actually optimize. So to do that, let's click on schematics. Okay, so to do that, all we got to do is go to Simulate, Optimize. Now, when you are optimizing an EM structure, the optimization method that you need to use is discrete local search. I've tried other ones and they don't work. I think this might be the only one you need to use, but don't quote me on that. But I do know that it works. So discrete local search. You can make your maximum iterations what you want. I'm going to make it just kind of 20, so it makes sure there's a stop there. And then everything's set. I'm going to hit start. Now this optimization is going to take a while because it has to do these EM simulations for each iteration. So what I'm going to do is stop the video now, and we'll resume when this thing is done optimizing, and hopefully we'll get the response we need. So signing off, and we are back. So it ended up taking more than 20 iterations to converge on a solution that I was happy with. And here are the results. And you can see that we are meeting our optimization goals, more or less. If you zoom in, it's not quite meeting it here at the corners, but this is good enough for us. And in any event, this video gave you the basics of how to perform an optimization on an EM structure in AWR Design Environment Microwave Office. So my work here is done.